guess something is not working here. This better? Yeah. Okay. So, this is a talk about NewSpeak, which is a language I developed some years ago. Some of you may have heard a lot of this before, but I figure you can use a refresher. Some of you have not heard about it, especially students and young people who, if I interest you, then it was worth my while to fly 30 hours to Argentina and do this. And if not, it was still worth my while. So, what is NewSpeak? NewSpeak is a language in the smalltalk family, but it isn't smalltalk. It's an evolution of smalltalk. And I'm very conscious of the fact that it's a very arrogant thing to do, to try and improve upon perfection, but nothing is perfect, and even smalltalk isn't perfect. And this is a language that tries to address some weaknesses. And Ralph's talk was a great lead into this, because many of those same points we're addressing through language means. And I won't have time to talk about all of them, but I hope to convey the essence of this to you. So obviously, dynamic class-based language, well, there are a lot of those, and smalltalk in particular. But what makes NewSpeak unusual is these two properties that are very unusual among programming languages, and certainly not what smalltalk does at all. So one is there is no global namespace, and the other is that all names are late bound. And we'll see what that means. And those two things basically have very powerful implications that dictate most of the other language decisions, and help make the language in particular very modular, and help address some of the issues that Ralph was talking about. So, no global namespace. So obviously some things have to change. We can't have global variables. We can't have pool variables. We also don't have class variables, because static state is really a problematic thing. Ralph actually alluded to some of those kind of issues. So we don't have those, and we don't have class instance variables, because they also could be perceived in some way as static state, and moreover, we're trying to make some class declaration be stateless. So what do we do? I mean, all these constructs are used, they have a purpose. It might seem difficult to live without at least some of them or all of them, but you can live a happy life without them. And what we do, we use nested classes to get around the problems. Now, if you know Java and know nested classes, forget about that. I am very, very well aware of what went on in Java with nested classes. And what happened there really was that there's a bunch of people who wanted to do the right thing. They were influenced by a beautiful language called Beta. Unfortunately, they had no clue how Beta worked. And they basically disregarded the fundamentals. And as a result, nested classes in Java were a bit of a train wreck. That was actually good for me, because it became my job to specify what they were going to do and try and, to the limited extent possible, clean up that mess. So let's look at what this means. Like, imagine you were doing a UI library. HopscotchForHTML is a particular library we have used that is used for it's a version of our Hopscotch UI library that's more restricted and used in the web browser for basically building UI for the web. And you could imagine that you might have classes like something representing a UI widget or unit or a text editor or a hyperlink in the web. And you might call them something like this, right? You might say, because it's smalltalk, it's good practice to disambiguate that you have this global namespace for your classes. And if you just called it, hyperlink or something, someone else might have a hyperlink and it's all going to clash. These classes likely communicate with the DOM and the document that the web browser has. And you can imagine a top-level variable called document, which isn't likely at all to clash with anybody else's document, like a word processor application or anything like that, right? So we have these problems. What happens with nested classes is basically you define a top-level class called HopscotchForHTML, and that's going to represent your library as a whole. Inside that, you can define individual classes like extender, fragment, etc. Right? So the first thing you can see is the trivial thing that it gives you namespaces in a way that isn't dependent on a tool, that is standardized in the language. But really that is the most minor effect, because this notion of putting a whole library and having this in classes is actually much more powerful than that. Because what happens here is that now a class is something you can instantiate. So now you can instantiate an object that represents your library as a whole. You can store it in variables, you can pass it around parameters, you can have it return from methods, you can serialize it, you can do all these things. Let's look at this in more detail. Not realize that I needed I think I'll be okay. And so I'll this up. So enter the instance variables of that top-level class called HopscotchForHTML. And when an instance of this class gets created, this code will get executed. Essentially what the syntax means, we have a class HopscotchForHTML, and this selector here, this is telling us that the class object will have a method. It will get an instance of an on the class object called using platform code. So it will take parameter key. And that will be the primary factory for this class. So basically we have HopscotchForHTML class, you send the message using platform with a suitable parameter, and that will cause this stuff here to be executed to create a new object, initialize this instance variable. And the thing is, since there's no global scope, the only connection between that instance and the world is going to be based on what I can pass in when I created it. Because it doesn't see the rest of the world. It's an instance of a top-level class. There is no global scope. There's no way to get at it. So everything comes in through these parameters. And we'll see how we use them for timer in a moment. But there's several things that you might want to note about this. For example, this implies that this code is naturally sandboxed. By definition, it can't get at anything that you didn't give it from the outside. Right? So we're going to see how we do get at things from the outside through the parameters. So here's timer. It looks like it's being initialized with this expression. This equality here, right? This equality is definitionally equality, right? This is the syntax for the class that entered it. Right? It is not a Boolean expression. It's being initialized to this expression right here. Okay. So it looks like we're sending a message timer to the actors. What this really is we're sending a timer message to the actors library. Right? And when you talk about asynchronous messaging and distribution and such, then actors are the idea that were sort of born with smalltalk-72 around the same time, but somehow the smalltalk world has not picked on that. A lot of the rest of the world, it took them about 40 years, but people have picked up in Scala and other places. So we use actors. And so essentially what happens here, you send a timer message to the actor in the library, and it will give you a timer class back. And this fits in with the idea that they all remain relational. You never reference classes directly in NewSpeak. When you define a listed class, automatically an access or method gets defined for it, and that's how you access it. You're going to send messages to the class, to the other class, or instantly from the other class to get that. Okay, so that's how we got a timer. The thing is, how did we get this actor library? Still, we just kick the can down the road. We just push the problem out one step, but we still not solve the step. And so what it looks like we do is by another message send. We send something called me. We send it to message actors, and that will indeed get us an object representing an actor library. And that's good, but where did D come from? Well, D came from right here, right? That's the formal parameter. And so, essentially, what we're doing here, when we instantiate something like HopscotchForHTML5, we have to give it a parameter that will support the various messages that we're sending here to the right? And it looks like we're getting timer from actors, we're getting order collection and dictionary from collection, so we get the collections library, access via message send and brackets similarly. So P is basically a platform object. It is an object that encapsulates the entire standard library that you can expect to have. And if you body of history, all these major components of the web interface we access to essentially, back up. And this is, of course, these aren't standard pages. They're not going to emulate APIs. Java. Yeah, okay, so yes, I'll repeat what the question is, but I repeat what I'll disclose from. So, when to instantiate HopscotchForHTML and this class, when to instantiate it, you pass it a parameter. You call using platform, pass it a suitable platform parameter. That is when it gets run, right? So all of these, and then that is when all your instance variables will get initialized. Unless you want to initialize them later, right? So a few details, as I said, with equal sign, that means equality. That means that these instance variables won't change later, right? So we're only going to create an accessor method that gets them, right? It'll be a method name, color, or map, or what have you, and that will let you get the value of this variable, but we're not creating a setter method. There is no way to change them, because in fact, the vast majority of instance variables are initialized not only in smalltalk, in a lot of other languages. There's lots of actual empirical studies to back this up. They get initialized in the constructor when the object is created, and they don't get changed later. Now, if we wanted to change them later, there's a syntax to do that. If we wanted to make it say this is changeable, this syntax defines a mutable variable. The shorter syntax is for immutable variables. To basically encourage people, like final variables in Java, right? To encourage people to use those by default. If you do this, then what will happen is there will also be a setter method. There will be a method window colon that you can use to set the variable. The point is, you never access the variable directly, just as you never access the class directly. Everything goes through a message thing. So if, for example, you decide to replace it with an instance variable window with a computation, with a method that's going to fetch it for you somehow, no code needs to change except for this definition here. Right? No code in your clients, no code in your subclasses, no code in the class itself, nowhere. Because everywhere else is going through a message thing. Right? So that's another nice property we get from this dynamic binding. Of course, we don't want to do this. Right? So overall, what we see here, this is our mechanism for importing. Right? This is how we get things from the outside world. Everything is Sandbox, which gives us a security story that I'll talk a bit more in a moment. All the dependencies are listed here, we can see them. And we don't have any static state. Everything is defined as an instance variable. There are no class, pool, etc., etc. Elliot? Can you speak up? Some of us are...
Right. So, just to talk about now with the two context. The first 5 imports that you show there are well formed in the sense that the names that are used inside correspond to the names that are imported.
Right, and actually the first 3 are, the next 2 are not.
Right, the next 2 are totally not. And we know that there's a certain egregious example in the version control where the person who chose to do this chose to rename by abbreviate.
So this is really, given 30 minutes, the level of detail that I have no intention about talking about. Right. So, let's go back to our slides. Okay. So, just to recap some of these things, we refer to top-level classes as module definitions, because essentially are this modular structure. As opposed to modules in almost any other language you hear the name, which are not actually modular at all, their instances are called modules. And they have this advantage. Being instances, I can create multiple instances, right, with different parameters. So I can lock things up, I can configure them differently. I essentially don't need dependency injection frameworks or all these other horrors because it's all basically injected by default. You cannot actually do it wrong. The fact that I don't have a module definition really doesn't have external definition, right? It But the code itself is completely independent. That means this code can be compiled in any order. It doesn't matter if other things are loaded in the image, or in what order they were loaded, or whether there's an image at all. This thing can actually be completely independently, separately compiled. Right? And yeah, we said there's sandbox. So I can guarantee you, if you want to know that for security purposes something doesn't access reflection or doesn't access a foreign function, right? Because foreign function calls go for not a primitive, you don't write some primitive that's embedded somewhere in your application. Because what actually happens with foreign function calls is you call an object called alien. An alien object that came from the alien module that you imported. I can guarantee that if you did not import aliens, you are not calling anything, calling C and undermining the semantics of the system, which you could what you call C all bets are off. So you can control basically exactly what this thing is doing, what it has to access. Yeah, there's no static state. Each of these guys I can have multiple versions of this thing, and they're not going to step on each other. What else? Right. Said that. Yeah, you can have different implementations. Say you do collections, right? Let's look at collections here. So you have collections. So this is the collections library, and I can have different implementations. Say for different purposes, right? I have different algorithms that have different space or time characteristics. I can implement this just like any other class. I can implement the same interface, the same protocol. I can do this at the library level. And these things can coexist. They can be the same application. I could benchmark this thing without going to any special lengths of loading and unloading or anything. That I can have all these things in my program without doing concurrently and just pass them through routine and the same API. All right, and this is where all these questions, collection, and all the interfaces are there. They're next in the slide. Right, we set up this. Set that. We set this. So we have to set this. So, okay, if you only access classes via methods, then you can override those methods. Right? Just like other methods. That means that all classes are virtual. Right? You can change their binding. So you can do interesting things. You can do class hierarchy inheritance. Modify whole libraries, whole hierarchies as a unit. And so we look at this is actually based on a real issue on the web world. In reality, they do listed things in JavaScript, but this came up in Dart, and Dart can't cope with the situation. But the DOM is being extended with experiments with all kinds of proposals for changing the web browser, etc., etc. And you can't plausibly say, oh, download my version of the web browser where I've implemented this experiment. Right? It's just, it's a massive thing when you do that. What you can do in JavaScript is modify the prototype and so forth. But JavaScript is very messy. How can you do such a thing in a principled way? If you had done this in NewSpeak way, the DOM would be a library, which would be a top-level class with all the elements and button elements and things embedded in it. And if you wanted to extend it, you would create a subclass, and you then subclass elements. Or let's suppose you wanted to add something to elements. I don't know, touch, right? So what do? You could create in the subclass your class element and have it override them basically by virtue of the same name, and it's going to be accessed by it. It's overriding the class element in the original library. Now, since we do want everything that we get from element in the original library, we basically inherit from super element, right? Because again, the super class is late bound, right? It's an necessary as well. The semantics are the first time you actually ask for the class to get its access to it. The very first time you do that, that class will be created at that point. At that point, you will evaluate its superclass expression and build a class, and it will evaluate that one time. So we're trying to get everything in the super element right here, and then we'll have an element class that has our new reflection. The thing is, any other class that extends element, like button element, when it gets created, it's going to call a class out of the element. It's a method. It's going to get this one and not the original one. So I don't have to go and tamper with all the 50 or 100 classes here. I just do the spot modification. This is very analogous to what you do with modify method. Right? It's inheritance, but it's at the class level for whole libraries. And you don't have to do this very often, but when you do have to do it, it tends to do something that you couldn't really possibly do in any other way.
So does creating a class element makes that reference to element you use that in class?
Right. Yeah.
So it makes sense.
Yes. So it's going to be found, right? So you have an instance of my and you ask me, of course,
What are you sending messages for? I mean,
okay.
if you want element new, for example, new is sent to element,
Right.
but element.
Okay, so it all depends on what scope you're in, right? But at some level, within this library, of course, it's in scope. You're actually, it's basically self-set. If you're doing outside, you need an instance of Python or not, right? An instance of the library. Just as we saw with those imports. Remember, we did platform, actors, Python, right? So we got an instance of the library, we send it the message, yes, it's the class. Let's suppose I had MyDOM, and it's MyDOM, and I want button element. I say MyDOM button element. What that does is evaluate, go through the definition of button element, which happens to say that it's superclass element, would send the message to an element, again, to the same class, which gets us the overridden definition. So all of it works by self-referencing. It works exactly like it does with methods. Just needs a little bit of use. But there's actually no new mechanism here. So that's very powerful. And we got all this for free from the fact that all names relate. That also means that we have sort of mix-ins automatically, because again, given that the class body is late bound to a superclass, that's essentially what a mix-in is. Right? If I override a superclass, then I will bind this body to a new definition. To make it easier, there's also a syntax for that, so you don't have to go through that. But the implementation has to be able to hold the same. Right? So we get class in there, we get hierarchy inheritance, we get mix-ins, we get security, sandboxing, etc. We get a whole lot of powerful features that out of a couple of decisions that get rid of global scoping and make the system more consistently use messaging. As far as security, right, it's important in this model that you can't get at the internals of objects. Now, you can't get at the internals of objects with smalltalk either, except that you can't really control what is an internal or what isn't. If it's a message, you define it via code, it's a method, and it's public. And all you can do is beg and pray, oh please, this is private, don't use it, but you can't enforce that. That's not secure. Right? If it's variable, okay, it's encapsulated, that's nice. But if you ever need to do something, you can't do that. Now, in a model like this, we're never accessing instances of variables. We're always accessing messages. If we take small talk semantics, it'll be public, and that can be very secure. So we do have essentially an access control method mechanism. If we go back and look at our There's a name for this model. Someone mentioned E earlier, right? This is essentially very closely related to E's OCAP model, where basically security is based on capability. What objects you have. You only do things by calling messages to an object. If you don't have the object, you won't be able to do it. There's nothing out there, global scope or some special syntax or anything that let you do these. Right? Unlike, say, smalltalk primitives. Right. And that. Okay. I don't know how I'm doing on time, but I'm pretty close. Even my timekeeper is not saying how much time. Yeah, I have an hour left. I just wanted to give you some information about the status. There's a lot more to say, obviously, about many of these things, about factors, about tons of things that I'm not going to talk about. The way implementation is, as I said, based on Squeak. And on Windows, we have a native UI that we actually can go to Windows. That's something we wanted to do with and not have time to do on other systems. Aliens, basically, we developed aliens, developed aliens for the system at some point. We have a JavaScript implementation, that is, it runs files into JavaScript and it runs in the browser. We are not talking about a front end to a server. We are talking about the thing actually a rich client running completely in the browser. And I'm going to show it to you in a moment. And obviously that one is not as complete. HopscotchForHTML, the library I showed you, is much smaller. The real Hopscotch library is lacking certain things. This is mainly a matter of volunteer labor. The IDE is incomplete because we can't change the shape of classes on the fly. Right? We have to. What we actually do is develop a smaller thing that is deployed on the first button into JavaScript, but we like to run the IDE thing completely in JavaScript. We can change methods on the fly. We cannot change the shape of objects on the fly. It's not impossible, but it's damn hard in the browser, and we sort of have a theory how to do it. There's issues of what it'll do to your performance, because the JavaScript is unlike smalltalk is, or they don't actually understand this is something you actually want to do. They assume you're doing this because you're some JavaScript wacko doing some very strange things, and they sort of your code will get de-optimized and go down to the trash that you're going to use. Plus, there's a small problem finding all your objects lazily. It's an interesting exercise. I like to do it, but we have to likewise, we don't have a debugger in there. There's all the debuggers in there. Right? I know exactly how to do a proper debugger there, but it's not too hard. Again, it won't work. And there's one here, there's minor corners of features that don't work the best way. But you can actually write stuff in the browser. In fact, let's try and show you that. Where did it go? Right, so this is the web browser, right? Everybody can see this. And here we have, right, this is NewSpeak code that I can evaluate. Right, so trouble 7. So we can actually see these are proper smalltalk semantics, right, of the ordering of operations. And the nice thing is, right, that I can click on this. This is the link. And now I find out the number. side, and that's another detail. And then I look for browsing for HTML, which is kind of the ID module here. This surrounds the class editor. And now I'm going to different color, right? So this is what you guys are used to, but we're doing it in the implementation and running in the browser. And it's actually probably faster than before. Ryan has a benchmark, so it's very competitive. It's not competitive with V8 and JavaScript if you do it straight, because they have armies of people working on this, but it's fast enough. Let's see, where are we? Right, those are the main, let's show you this. Right, there are a few other implementations work in progress. It seems that it's almost something like probably 50% of the people who use NewSpeak do their own implementation. It's easy to work with in the small help community with their, it's like every cat, everybody has their ideas. Ryan, who's done a lot of work for us, now has his own C-based implementation interpreter. The nice thing about that is it made around to be very simple for mobile, and it still needs some work. There are two Java-based implementations that people are working on. Again, they're not really complete enough to use. One is based on the Truffle Browser virtual machine framework that Orgos put out. It's Stefan Mar, he's an academic researcher in Austria, and it's called SOC-NS. That's I forget what S means, small dog, or maybe simple. It's some object machine, NS is the NewSpeak, and this has amazing performance numbers, right? This thing can run at 65% speed of the production job, and just one reason. It, of course, also lacks schema change here, all kinds of stuff, and compatibility, but it was interested in really active but, if one could make something of this. Free copy is something the city is working on. Again, it's not even public. I don't know if it'll ever go anywhere. But so that's plain Java 8. But that means that we can deploy it anywhere. And there's support for them there. People are experimenting and getting multiple results. So there was a Dart implementation. We abandoned that for various reasons, and basically got. And you can look at our web page. It's open source. But we want here. I like this quote. It may not be what I intended, but I think this works as a wish. So it fits with what we're doing. And that is pretty much the highlights that I can cover in whatever time I go. And thank you very much for listening.
How different is NewSpeak VM from regular flow? I mean, how?
Well, there's some extra byte code. We can ask Elliot, but then we'll never get into lunch or anything. Yeah. Basically, there's some byte codes and the basically semantics are different for two major reasons. One is you have this nested thing going on, right? So you have messages that have to look up not only in the class directly around you, but also up the lexical scope. I didn't explain the exact rules, but they're actually quite intuitive when you use them. They're rather tricky when you actually have to figure them out. So that's the main thing. And the other thing is the access control. The lookup also is the access control. So you have to actually distinguish between what methods you can invoke. If they're public or private or protected. So those are the fundamental.
And there's also actually receiver sets. There's a real bad part of the small micro set is security, which is the arity of the selector is in the bytecode, not in the selector. So if you mismatch the reasons file stuff, you can lie about the arity of the selection. both 3-argument selector or 4-argument bytecode.
Yeah, like JavaScript.
Right? And then there's also this thing of the production of the receiver is separate from the message segment. And so in NewSpeak, we said we have the ability to say, okay, we're going to send this message, but we're not going to have an expression for the receiver. The receiver is implicit. Implicit setting. But basically, these changes are minor and fit to be exactly the same model. So it's noted.
You have to implement a handful of bytecodes to do the lookups correctly.
Mostly for security.
It's not just for security. But the access control is for security. The lookup needs to be different for semantics and performance. Because if you try to do this scoping thing without that, that's how it started. It doesn't work very well.
You end up doing twice the work. You end up having, when you produce the receiver, you have to do all the scope lookup. When you do the message send, you have to do all the scope lookup. If you get rid of the first part, you have
It's worse than that, right? Because the lexical elements, realistically, you want that support as well. Okay.
Yeah, that's another question for security reachability. But you have to change not all instances implementation. Well, maybe yes, all instances or all references, like all those introspection methods.
Right, okay. So what's the story for that, right? So number one, yes, there's no direct access to privileges, right? You have to go through a gateway scaling, or through reflection, you have to go through the mirrors, right? So the basic mirror library, which is the only one that actually exists, the backstory that there should be more, right? Gives you all the power you want. If you don't access, if you don't have that capability, you can't do that. Realistically, you would probably like to have attenuated mirror libraries that didn't give you some of these capabilities, that gave you partial, like you can only call public methods or things like that. And they would basically be a version of where you pass them in instead, and you have the same strengths and issues as capability systems, like what are capabilities lead to?
So it's also solved by rituals.
Yeah. Everything is done uniformly that way.
Okay, thank you very much.